job, good job. All right, 5.1 was just the basic introduction to probability. You know, what if I do just the basic pull in a hat and grab out an M&M? Now we're getting into a little bit harder probability. Now we're doing a couple of different things. What if I roll a die and I want a couple of different things to go on? So we're going to, and the good news is we have some formulas on our formula sheet, so don't feel like you have to memorize these. And I'm going to pull up on your formula sheet what they look like. We're going to talk about the addition rule, the general addition rule, and complements. Not like I'm telling you that you look beautiful today. It's going to be a different kind of compliment. The addition rule for disjoint events. Disjoint events mean they have nothing in common. No outcomes in common is a disjoint event. A disjoint event means they have nothing in common. That is a disjoint event. So the rule says the probability of E or F happening is the probability of E and the probability of F. That is if it's disjoint, if they have nothing to do with each other. For example, if I say, what is the probability of you rolling a 3 or a 4? Do you agree that you rolling a 3 and you rolling a 4 have nothing to do with each other? 3 has nothing to do with the 4. Those are disjoint. They have nothing to do with each other. If this would have said the probability of you rolling a 4 or rolling an even, those kind of overlap. A 4 and an even have stuff to do with each other. So a 3 and a 4 have nothing to do with each other. Those are disjoint. So we're going to find the probability of a 3 plus the probability of a 4. So we're going to look at them as two separate things. So what's the probability of a 3? What makes me happy is a 3. How many 3s are on a die? And how many total sides are on a die? How many 4s are on a die? And how many total sides are on a die? So we add up both of those. 1 plus 1 is out of 6. And 2 6 is going to reduce to 1/3. So if you have two things that have nothing to do with each other, you treat them individually. You find the probability of a 3, you find the probability of a 4, and you add them together. Make sense? If they have nothing to do with each other. Now, if they have outcomes in common, what we've got to do is we got to take out what I call the double dip or the overlap. So for this one, and let me pull so that I can cover up as we go. For this one, I'm asking you, what is the probability if you roll a die and I'm happy if you get a 2, or I'm happy if you get an even number? So do you agree that if I got a 2 and I got an even, some of those answers overlap? Just like if I got a 3 and I got a 4, they didn't have anything to do with each other. But if I got a 2 and I got a 4, some of those answers overlap. So I've got to do the 2. And I've got to do the even, but I've got to take out the overlap, which is what I call double dipping. Okay? So, I'm going to come up here for just a minute, or over here, or around here, or I'm going to come somewhere. I'll come up over here just a second. So, do we agree that our sample space, there's 6 of them? What makes me happy for the first one is a 2. So what is the probability of getting a 2? 1 out of 6, right there. 1 out of 6. What's the probability of getting an even? 3 out of 6. But then I'm going to add those up, but I have to take away my double dip. What is my double? How many double dips did I have? This was my double dip. It happened in both of them. So I've got to take away my double dip because I don't want to count it twice. So I'm going to take away my double dip. So I have 1 2 that makes me happy, 1 6, and I have 3 evens that make me happy. So I put those together and then I take out one of those that I double dipped on.
So you use a double dip numbers in that. Oh, it's 2 E. Oh, okay.
So it's going to be 1 6 plus 3 6 minus the 1 6 because you don't want to count that number twice. So you're taking out the overlap. You don't want me to show that so y'all don't have to? Okay. So you take out they like listening to us teach. So you take out the double dip. So 1 plus 3 is 4 minus 1 is, so your answer is going to be 3 over 6, which is 1/2 or 0.5. I didn't have to do it for the 3 and the 4 because it didn't overlap. There was no double dip. See, if I come over here, if I do a pictorial over here, 1 2 3 4 5 6, the 3 is the 1 6 and the 4 is the 1 6, but there's no overlap. There's no double dip. There's no intersection or anything. Yay? We're going to do more of these. This is where it starts getting a little tricky. Now the complement is the rest of the story. The complement is the rest of the story. If I said the probability that it's going to rain is 40%, the complement of that is going to be the rest of it. So 40% is going to rain. What's the rest of it?
60%.
If there's a 75% chance that you're not pregnant, what's the complement of that? 25%. So the complement is the other part. Either you're pregnant or you're not pregnant. The complement is the other part, the rest of the story. So the complement is what we call the not. The complement is usually the not, the other part of it. We also use the terms, if they share outcomes, we call it mutually exclusive and not mutually exclusive. If they share outcomes, which was like the 2, they share outcomes, example, the 2 and the even, we say they're not mutually exclusive. The 2 and the even, they're not mutually exclusive. If they do not share outcomes, for example, the 3 and the 4, we say they are mutually exclusive. C-L-U-S, I could spell mutually, E-X-C-L-U-S-I-V-E. Not mutually exclusive. So if they share outcomes, like these had overlaps, they had double dips, then we say they're not mutually exclusive. If they do not share outcomes, they are mutually exclusive. It's kind of backwards of what it sounds like. I just want to make sure you know that terminology. Mutually exclusive means they're independent. If I say I'm mutually exclusive of you, that just means I'm independent. I have nothing to do. I am mutually exclusive. I don't need nobody else. I am alone. I don't need nobody. I don't overlap with nobody. I don't have anything to do with anybody else. I am mutually exclusive. A complement is everything that is not, oops, I forgot my G. Everything that is not within that group. So it's the not, the everything else.
Could you scroll up a little bit?
I can do whatever you want me to do.
Oh, that's good.
Okay? And this is just some terminology to help us with the rest. Mutually exclusive is independent. It does not have anything to do with anybody else. It's single. Complement is going to be the not, and it's going to be everything that's not in that group. And I'm going to do lots of examples. I just want to make sure you know the vocabulary. And we're going to have, we ran into this a little, a couple of weeks ago when we talked about and or. I think Austin didn't like this when I used the word or. When we were talking about something and you said, or it can't be in both of those. There's a big difference between the word and the word or. I have a child and a stepchild, and sometimes I say, you know, I want to make this person and this person happy. Versus I want to make this person or this person happy. Okay? There's two different things when I use the word and use the word or. If I want to make both of my children happy, if I want to make Josh and Madison happy, they both, it has to be in both of their lists. If I want to put it on both of their Christmas list, it has to be on Josh's Christmas list and on Madison's Christmas list. It has to be in both of their Christmas lists if it's an and. If I say that I want to make Josh or Madison happy, then it could be in one Christmas list or the other. I could buy, you know, something with frills, or I could buy something with hunting. So it's harder for me to do this than it is for me to do this. This has to be in both of the lists. This can only be in, can be in one list, or it can be in the other list. This has to be in both lists. It's kind of like when I got divorced from my baby daddy and I was looking to marry my current husband. You know, you start off by saying, I want somebody that's tall and rich. I want him to be tall and I want him to have money. And then, after a little while, you're like, maybe I need to change that to or. Not as picky. You know, I'll be happy if he's tall and broke. I'll be happy if he's rich and short. If it's on one list, I'm happy. Doesn't have to be. So this is when I'm pickier. It's got to be in both lists. This can be in one or the other. So there's a big difference when I use the word and versus using the word or. See the difference? All right. Now, let's cover up for a second. We have several sample spaces. This is our total sample space. Our sample space is the numbers 1 through 12. So we have 12 pieces in that sample space. Then we have these baby samples. We have E, F, G, H. We have 1, 2, 3, 4, 5, 6 pieces here. We have 5 pieces here. We have 4 pieces here, and we have 3 pieces here. Yay? We good? Now, number 5 says they want me, I'm gonna put it over here so you can't see my answer. They want me to find E and F. So I'm happy if it's in E and it must be in F. So it's gotta be on Ella's wish list and on Frank's wish list, and it's gotta make both of them happy. What do you think my answer would be?
3. Three.
Who?
3.
What pieces?
5, 6, and 7.
These are the things Ella wants for Christmas. These are the things Frank wants for Christmas. And I've got to make Ella and Frank happy. So the things that make both Ella and Frank happy are 5, 6, and 7. You with me? Now, they have overlap, and what I'm going to do, for those of us that can't visually see, I'm going to pull, copy, paste, pull, see if I have a little bit of room right there. And because it's an and, it must be in both. So 5 is in both, 6 is in both, 7's in both. That's why that's my answer. All right, my next one. F and G. F and G. What is going to be my answer for F and G? It's got to be in F and it's got to be in G.
8. No, 7.
All right, here's my F. Copy, paste, and then I'm going to pull my G down. Oops. Over here. Here's my G. Copy, paste. And means that it has to be in both. The only one that is in both is going to be 9. Now, I'm going to pull this down to another page just so that you can see. Copy, paste. What if I would have said F or G? What would you have told me?
Would you put 5 to 12?
Yeah, just 5 to
Because or means I'm happy if it is in either of my child's list. I'm not as picky. I'm happy if he's tall. I'm happy if he's short. I'm happy if he's rich. I'm happy if he's poor. So if it's in his list, I'm happy. If it's in her list, I'm happy. I'm going to get it. I don't need to list it twice. It's just in their list, I'm happy. So if it's in either list, I put it if it's an or. If it's an and, it has to be in both lists. You with me? All right. Let's go back. My next one is, really? That was my next one. I am that good. Okay, this one is the probability though. It didn't say list it. It just says give me the probability. So, what is the probability of F? 5 out of How many total are there? 5 out of 12. What's the probability of G? 4 out of 12. But we've got to take out any double dipping. What is the double dipping between F and G?
9.
So how many is that?
1.
So, we've got our 5 out of 12 and our 4 out of 12. Our 1 out of 12 is the number 9. That's the one that overlaps. So 5 plus 4 is, 9 minus 1 is, there's our 8 twelfths. All right, let's look at another one. The next one is E and G. E and G.
There,
There are no.
0.
E and G means we have to make both children happy, which means it has to be in both lists. Is there anything in both lists? So what you do for that is you say, where's my E and G? Or did I skip one? Oh, I skipped one. Hold on, I'll come back to that one. For that one, you put, it's called the null set. You put squiggly lines with nothing in it, meaning there's nothing they have in common. That one's called the null set. Well, I don't have to know the name, but I'm going to tell you the name. Meaning they have nothing in common. All right, let me go E or H. E or H. And we're doing probability. Probability of E.
6 out of 12.
6 out of 12. Probability of H.
3 out of 12.
3 out of 12. Is there any overlap?
Yes. 3 out of 12.
3 out of 12. So it's going to be 6 over 12 plus 3 over 12 minus 3 over 12.
So just 6 over
6 over 12 plus 3 over 12 minus the overlap, which is 3 over 12. So that's 9 minus 3, which is 6 over 12. Okay, next one is F and H. F and H. F and H. No probability, just what is in F and H?
No.
The null set. In order to be an and, it has to be in both of them, and there's nothing that's in both of them. That's the null set. The complement of E. Okay? If this is E, the complement would be everything that's not in E.
1 to 8.
1,
10.
8, 9, 10, 11, 12. What would be the probability of the complement of E?
6 over 12.
6 over 12. What's the probability of the complement of F?
7 over 12.
7 over 12. If there's 5 in there, there's going to be 7 that's not in there. So if I tell you to list the complement, it's going to be, for this one would be 1, 2, 3, 4, and then 10, 11, 12. So the complement is all the pieces that are not in here. And the probability would be all the pieces that are not in there. So, we had already done the null set. The complement is all the pieces, and then the probability is going to be all the other, there were 6 in there, so there's going to be 6 out of there. And then we did F, all the pieces. There were 5 in there, so there's going to be 7 out of there. All right, let's see what else we have. Okay, I just did that one. Now, on your formula sheet, let me select all and move down so that I can show you what your formula sheet has. your formula sheet, we are in chapter 5. Now, get so that I can reach it. In chapter 5, there's a lot of stuff out here. Both of these, this one just says how many times it happens over the total. So if you reach in there and there's 40 red tulips and there's 100 times you pick a tulip, then it was 40 reds over 100 tulips. Remember when y'all did that one? This is the number of ways E can occur. This is what makes me happy over total. The number of ways E can occur, I pick out 30 red M&Ms and there's 100 M&Ms in the thing. This is what makes me happy over total. Now, what we're talking about over here is the addition rule. This would be, let me think of an example. I roll a 3 on a die, and I roll a 4 on a die. What's the probability of me rolling a 3 on a die? What's the probability of me rolling a 4 on a die? So 1 out of 6 plus 1 out of 6. And if I have multiple events, like rolling a 3, rolling a 4, rolling a 5, rolling a whatever, I would just do it that many times. This is the double dipping. I roll a 2, and then I roll an even, and then if they have anything in common, I'm going to take out that double dipping. And then here is that complement. If it's going to rain 40% of the time, then we're going to do 1 minus 0.4, which would give you the other 0.6 or 60% of the time. And most of y'all do that in your head, but it's 1 minus whatever, which is 100%, minus the decimal. So, let me pull these formulas over so that we can have all of those formulas at the top of this page. And have that complement formula. So these are not formulas you have to memorize, but they are formulas that you're going to have to know when to use them, how to use them, why to use them. So I can put him right up underneath there. All right. Now, in the directions, they tell you what PE is, the probability of event E and the probability of event F. And they're doing a PE or F. So we're going to be using this one just in case there's any overlap. So, if I use that formula, they told me what that is. That is 0.25. They told me what that is. That is 0.45. They told me that PE and F is 0.15. They want to know what is that. So all we're going to do is just plug it into our calculator. 0.25 plus 0.45 minus 0.15. They're just making sure you know how to use the formula. 0.25 plus 0.45 minus 0.15. There's my answer. There's really no word problem. They just want to make sure that you know how to use the formula. So the formula you got from the formula sheet, they told you what PE was, they told you what PF was, they even gave you PE and F. You plugged it in and solved for that. Plug and chug. Now, I am on 13 through 18 in 5.2. Let's look, y'all. 5.2. Do you see 13 through 18 in 5.2? 13 through 18 in 5.2. We just need to know how to do this for the homework. All right, let's look at the next one together. Then I'll give y'all one. Okay, the directions they gave us up here. Copy. Same directions, all of this is given. we are doing the same formula from right here. The same formula. PE or F equals PE plus PF minus PE and F. This